Hi, everyone. I'm Ginger Creek Dosier. I'm CEO and co-founder of Biomason. So, imagine a world where we could switch off the kilns of the most ubiquitous material on our planet. Concrete is the second most consumed substance on the planet following water. Cement, which is the vital part of concrete, which makes it strong, was invented about 200 years ago. And unfortunately, it has a bad side effect, where it emits about the same amount of CO2 that's produced. But the invention of concrete and Portland cement has enabled us to have massive towers and construction that we can only imagine. At Biomason, our North Star is to eliminate 25% of carbon emissions from the concrete industry by 2030. It is a highly aggressive goal. This industry drastically needs decarbonization, and we believe we have the solution for it. So I started Biomason 10 years ago as an architect, being inspired by coral, and tried to understand how are we able to grow these strong and durable solutions in a marine environment, and what can we do to learn about the blueprints found in nature. So what we do is we eliminate CO2 from cement manufacturing. So to be able to make cement, you take limestone, you mine it, and you burn it at high temperatures, and that's only to get the calcium. And that means that the carbon just freely emits. There's a lot of attention right now on decarbonizing cement, and we're excited about that, but a lot of the solutions that are out there are really not solving the problem. And at Biomason, our mission is to cure the disease rather than treat the symptoms. And instead of using a kiln to burn calcium carbonate, we use biology to grow our own cement. Right now, we're concrete application agnostic. To take out 25% of emissions from concrete by 2030, that means it goes beyond precast. It goes into ready mix. But over the years, what we have found is a really wonderful entry point with precast. And we're excited about partnerships that we have with companies like H&M, because for them, they have been privatizing a lot of the sustainability objectives by demanding that more materials like this are available at an even faster rate. And that's exciting for us because we're in a hurry with our 2030 goal. So how do we get 25% of carbon emissions out of concrete by 2030? Well, it's a very fast and accelerated licensing model. Right now, we're very busy working to accelerate our partners to produce whatever they want in terms of their concrete products. And that means that biology is really our fundamental technology. We provide a solution to them, which is drop-in, so similar to the gray powder that they use today. We're excited right now. This is a plant that opens up in Denmark later this year. So it's exciting to see our business model really come to life. There's a lot more work to be done in this year, and we just closed a nice round of funding, so it's exciting to have some acceleration from there. Something that's also exciting about using biology to grow cement is that you can decouple away from the kilns and away from the fuel sources, meaning that you can have distributed manufacturing, meaning that you could grow cement closer to cities, whereas now it's prohibitive because of all the emissions. So we're excited about the flexibility that building with biology offers us. For us, it's about derisking. I'm an architect by training, so even in the early days of Biomason, we started our own ASTM labs. We work with several third parties. There's a lot of great attributes to biocement. There's a lot that we're learning. Portland cement was invented 194 years ago, so there's plenty to learn, and we're excited to be fascinated by what else can biocement do. So there's a couple of upside opportunities that we have. One is that we've been working with the Department of Defense on some essentially treating helicopter landing pads. There's quite a bit of foreign object debris that destroys a lot of the helicopters. So working with them on things like this, working with the Air Force on solidifying runways so that they can land heavier and heavier aircraft. And this isn't something where Portland cement is used for today, but this just shows another opening for materials like biocement to have a place. And then lastly, another upside application that we're also excited about is living shorelines. There's quite a bit of rising sea levels, so looking at the materials that we put in our marine environment. What's different about this is that concrete is a terrible material to work in the marine environment But for us, we're able to participate in the natural environment and be able to absorb CO2. Thank you all. We're ending the world's dependence on carbon-emitting construction materials by delivering on a world built with biology. Thank you.